Number 1 is synthetic division. We have 3x squared plus 5x plus 5, and we're dividing this by x minus 3. X minus 3 would give us the synthetic divisor of 3. We're going to set up our synthetic division. Make sure you identify all of your coefficients. Your synthetic divisor goes on the outside. Your coefficients of -3, 5, and 5 go on the inside. You add inside, you multiply on the outside. Synthetic division gives us a remainder of -7. If we scroll over to number 2, we have the same function. So notice in both of these, we are using f of x equals 3x squared plus 5x plus 5. And in this case, we are evaluating the function, but we're evaluating it at a value of x equals 3. Also similar to our synthetic divisor on number 1. Evaluating functions is when you take your x value and you substitute it into the function wherever you see x. For this function, we have f of 3 is equal to -3 times 3 squared, which is 9, plus 5 times 3, plus 5. -3 times 9, or times 3 squared, is -27. 5 times 3 is 15, plus 5. When we simplify this, f of -3 is equal to -7. So what I was planning on everyone noticing is that the remainder for number 1 using synthetic division and the answer for number 2, evaluating the function, both come out to -7. You also, again, should notice that the functions are the same and your synthetic divisor compared to your evaluation term, they are the same. So you're getting 2 of the same answers, but completing the problem 2 different ways. So this leads us into the remainder theorem. The remainder theorem says that if you divide a polynomial by a linear expression, such as x minus a, the remainder will be the same as evaluating the expression at a. It will probably be easier to understand the remainder theorem if we just jump right into going over example 1. So example 1 says to use synthetic substitution, which means we have to use the synthetic process to do this, and the remainder theorem to evaluate each function. So if you are using the remainder theorem, you are only evaluating. You do not need to write your final factors. You don't need to write your quotient plus your remainder over your divisor. You are just evaluating. So we are only looking for the remainder. And this is why it's called the remainder theorem. Number 1 says x to the 5th minus 2x cubed minus x squared plus 2, and we're evaluating it at x equals 3. We do have to make sure we include all terms, so rewriting this as x to the 5th plus 0x to the 4th, because we're missing that term, minus 2x cubed minus x squared plus 0x plus 2 will be helpful. Look at all of your coefficients. And what you're evaluating the function at, this is already set equal to 3, or x is already set equal to 3. It is not in the form of a factor, So you do not need to change the sign. You are just going to use the value of 3. Three goes outside. Inside are your coefficients of 1, 0, -2, -1, 0, and 2. Bring down the 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus -2 is 7. 3 times 7 is 21. 21 plus -1 is 20. 3 times 20 is 60. 60 plus 0 is still 60. 60 times 3 is 180. 180 plus 2 is 182. So this is your remainder. That is also the answer to your expression, or to your evaluation problem. So we write our final answer as f evaluated at 3. We're using 3 because it says x equals 3. So f evaluated at 3 is equal to 182. This is what the remainder theorem is. Instead of substituting 3 into the problem wherever you see x, you are just going to use synthetic division. Whatever your remainder is, that's your answer. I'm going to go through number 2. You can just follow along with me. I'm not going to talk through this one. I think everyone should be pretty good with synthetic division by now. Okay, so now that we've gone through these two examples, make sure you understand how to write your final answer. That is part of the problem. So understanding that the remainder theorem is specifically looking for the remainder, and it's looking for you to write your answer like this, is part of this. So you have to write your answer like that on the quiz. I will be checking for that. Next, we have the factor theorem. So the factor theorem says that if the function has a factor, I used x minus a again, then the function has to have a remainder of 0. So we basically started off the notes with this theorem, but we just started off using long division as a review. This factor theorem is going to require us to use synthetic division and then to completely factor the expression. So the first example set 3, is just asking you to determine if the given binomial is a factor. So it's not asking for you to factor the whole thing. It's just saying state yes or no, is the given binomial a factor? You have to prove that it is by showing that the remainder is 0, or prove that it's not by showing that the remainder is not 0. So we're going to go through this the same way using synthetic division. This is not equal to 0. Previously, using the remainder theorem, it would say x equals 5. This is not the case. This time, this is a factor. So knowing that this is a factor, it's in the form of x minus c. In this case, c is equal to 5. Set up our long division. One, -7, 7, and 15 for our coefficients. Bring down the 1 and start the process. Oops. 1 times 5 is 5. 5 plus -7 is -2. Negative 2 times 5 is negative 10, plus 7 is negative 3, times 5 is negative 15, plus 15 is 0. So to answer this question, you would say, yes, x minus 5 is a factor of the original expression x cubed minus 7x squared plus 7x plus 15. And back at the beginning of this video, I explained the whole process of a factor. I used 24 divided by 6, 6 being the divisor, but because it works out perfectly, 24 divided by 6 is 4. That also means 4 is a factor of 24. So how divisor and factor can be used interchangeably if the remainder is 0. So same thing goes here. Because x minus 5 is a factor, or has a remainder of 0, it is a factor of x cubed minus 7x squared plus 7x plus 15. For number 2, your synthetic divisor is 2. We have all terms, so our synthetic division two on the outside, coefficients of 1, negative 7, 4, and 12. Bring down the 1. 1 times 2 is 2, plus negative 7 is negative 5, times 2 is negative 10, plus 4 is negative 6, times 2 is negative 12, plus 12 is 0. So this one is also a factor. I'm just going to say yes for this. We know what we're talking about on that. So yes, x minus 2 is a factor of the original expression x cubed minus 7x squared plus 4x plus 12. And lastly, the fourth example set here says to use the factor theorem and determine if the factors, to determine the factors of the polynomial. So this is just like that first one. Now we're using synthetic division. We have to completely factor the entire expression here. Using synthetic division for the first one, our synthetic divisor is 5. 5 goes outside. To complete the synthetic division, bring down your coefficients. We have 1, negative 7, 7, 15. 1 times 5 is 5, plus negative 7 is negative 2, times 5 is negative 10, plus 7 is negative 3, times 5 is negative 15, and 0. So yes, we have a factor. That's telling us that this here is what's left over. We would have x squared minus 2x minus 3. All right, so this being the quotient, this being a factor or the divisor, we can write an expression that says the divisor, or that states the divisor times the quotient equals the dividend. I'm not going to write that out, but it equals the dividend. And then underneath this, I'm going to write that our divisor is x minus 5, and our quotient is x squared minus 2x minus 3. You need to think and determine if that is factorable any further. It is. So our final answer is x minus 5 times x minus 3 times x plus 1. And the negative 3 and positive 1 multiply to negative 3 and add to negative 2. That's where those factors came from. This here is your final factored answer. And for the last problem, we have our synthetic divisor of negative 4. We are missing a term. We need to add in 0x. Bring down the coefficients of 1, 3, 0, and 16. 1 times negative 4 is negative 4. 3 plus negative 4 is negative 1. Negative 1 times negative 4 is 4, plus 0 is 4, times negative 4 is negative 16, which is equal to 0. Our quotient is x squared minus x plus 4. Now, this is the quotient, so we can write it as the quotient times the divisor, and that's equal to the dividend. And you just have to check to see, is this factorable? So are there two factors that multiply to positive 4 and add to negative 1? And the answer would be no. So this is your final answer, x plus 4 times x squared minus x plus 4. If you were to multiply those two expressions together, you would end up back at your original expression of x cubed plus 3x squared, plus 16. So for this note sheet, I can't stress enough how important it is to understand the different terms and how you can use different names for different things. I'm going to go over the same example I've gone over a bunch of times. I hope that everyone remembers what I'm talking about after you've seen this like 5 times on this note sheet. But if you have 24 divided by 6, 6 is the divisor, 24 is the dividend. We would write this as an expression in long division like that. Your answer is 4. 4 is your quotient. Now we have 6 times 4. 6 times 4 is 24. So our quotient and our divisor multiply together to equal the dividend. Okay, this only happens if the remainder is 0. Obviously, we're not doing anything as simple as this, but thinking about simple examples is what helps you realize what you're doing for more complex work. Also, the last big takeaway from this note sheet is please read directions and make sure you're understanding how to write your answer. So are you using the factor theorem or are you using the remainder theorem? How are you supposed to write your answer? Make sure you refer back to this note sheet and write your answers the same way I did.